this is the protocol. You already have this, but I'm gonna send you this last version again attached with this video. So basically, this video is a reminder of the protocol. If you have questions, please let me know. So first, when you get your QField project, you have to go to different sites of the Danum Valley area, but without looking at the gaps in advance. So you can look at some areas and you decide, okay, today we are going to be working in the trails that are the trails. Tomorrow we are going to be working south of the station. So basically just randomly select these areas, but don't look at the gaps in advance to decide those areas. So after you arrive at the site, so once you get to the gap, you have to make sure that the disturbance image that you see in the iPad is the same place where you are in the ground. So look for trees that might be important or relevant for you. So make sure you're in the right place. And then once you get there, make sure that there is at least one damaged tree that is a gigante tree, so diameter at breast height higher than 50 centimeters. Remember that damaged trees are trees that are damaged more than 10% of the crown, the tree, or the leaves. So these include also branches. If there is a big branch that fell from the tree and you can estimate that is more than 10%, of the crown, then you can include that. Also, you might get to places where there are not gigante trees. So there are no damaged trees, or there are biomass trees but no gigante trees. Then you only have to fill out the disturbance sheet and the disturbance attribute. This is also in the iPad. And there is a note here. There might be also a case in which this disturbance does not really affect the understory. So then you only have to take this information again in the disturbance sheet. Okay, so if you find gigante trees, so trees with diameters at breast height higher than 50 centimeters, but that are damaged, so they have damage caused by this disturbance, so this month, if they have all damage, let's say 3 months ago they lost some branches, so it doesn't count. It has to be damaged by the current disturbance. Then you have to start taking measurements for the gigante site. So remember, the first thing you have to do is you kind of walk around the gap and you try to identify what are the trees that you're going to be measuring. So basically, what are the trees with diameters higher than 50 centimeters that are damaged by the current disturbance? So you look at them and you're like, yeah, this is going to be a gigante tree. You can also identify biomass trees, so trees with DBH between 30 and 50 centimeters. And you also look at them, make sure that they are damaged by a current disturbance, so you have them there. And then you also have to find two control trees, which are the closest trees with DBH higher than 50 centimeters that have no damage or very, very small damage. If you cannot find two trees, it's okay to have only one. If you don't find any of them, that's also okay. But make sure you walk around the disturbance, so you make sure you cover the whole area. Also, as you remember, is it maybe easier to walk around with the iPad? So as you're walking, you are already recording the data, so it doesn't take a long time for you to walk around and then do it again to measure the trees. Remember, you have to measure the angle and distance from the center of the gap. So as we discussed before, one of you stays in the center and the other one walks around with the iPad, and you're always communicating. So one is typing in the iPad, the other one is measuring, or the other way, however it's easier for you. But make sure you're always communicating and yelling to each other the names and numbers and etc. So for site ID, in this case is danum, And the disturbance ID is the disturbance ID that comes with the gap ID. So when you get to your gap, which is the blue polygon in the map, it has a number, so that's your disturbance ID. If you know the species, you can write the species down. If not, you should take photos of the trunk and the leaf. This is how you have been doing it, and then you go back to the lab and try to identify them with your field guide, or ask people around for help if that's easier. You measure the diameter of breast height. For now, you can still use it. You can still keep using the app that we have been using before. The measurement app, I think, is called. That you can use to measure DVH that is very high, and you already know how to do that. Here it says to use this app, but I have to send you a video of how to do it. So for now, just keep using the iPad as we have been using it. So tree tag. If the tree is located within a plot from the 50-hectare plot or someone else's plot, make sure you write down that number, and do not tag trees within the 50-hectare plot or within other existing plots. If the tree is a gigante tree or a control tree, you have to add an aluminum tag. You already have this. And if it's a biomass tree, you don't add any aluminum tag. This is other information about how to add tags depending if the tree has multiple stems, so you should read this as well. So buttresses, remember these are the buttresses, so you only do this for gigante and control trees. You only count the number of buttresses that are higher than 1.3 meters. So let's say this is 1 meter, so you don't count this one, but you will count this one and this one. And then you measure the height of the tallest buttress with the laser. Okay, so now you have to record if the tree is dead or alive. Sometimes it looks that it might be dead, but if you use a little knife, or you can scrape the bark, and you can see if it's actually dead or not. If the tree is sprouting, so if it has little branches growing, it means the tree is alive. So make sure you confirm whether it's dead or alive before filling out this one. Okay, so if the tree is alive, there are some flags that you can add. If it's leaning more than 10%, so if it's going to one side, if it's fluted, fenestrated, which is like this one, if it has multiple stems, and again, if it has multiple stems, you go up here, and this is the information on how to write the numbers. If it's burned, but this is very rare, but the only way to know if it's burned, if you touch it and your hands look like coal, so like black, as when you're making a fire. If it's peeling the bark like this, you add a Q. If it has stranglers, S, and if it's sprouted, a B. So now you know if it's dead or alive. Now you have to record the mode. So is the tree standing? So basically, does it have the crown attached to the stem? If it's broken, then you measure with the laser the height at which the tree broke. If the root is broken, if it's uprooted, so basically it fell, but all the roots are attached, or most of the roots are attached to the stem. If it's twisted, if it's broken but it's attached, and if it died before disturbance. So if you go to the gap and you find the tree is very, very decomposed, so it's the wood is very old and it's almost like sand, you can see it's very, very decomposed, so it's likely that this tree died way before the drone detected this disturbance. You can also have flags to this one. So if you see that the tree has a lot of decomposition, so basically the tree is dead, and advanced decomposition is for the whole tree. So if the whole tree is already decomposing, Lining a scar, this is a very hard to see, but if you suspect that you see it, please take a photo and send it to us. Rot, so this is a little bit similar to decomposition, but this is localized and this is for a living tree. So this is here an example of advanced decomposition, and this is an example of wait, we don't have an example of rot. But do you remember, is like sometimes we have branches that are a little bit hollow inside and are black. So this means it's like decomposing, but in a localized place. So localized in the branches, and the tree is still alive. If it has stranglers, which looks like this again, and if it has flashovers, that we did some training on that when I was there with Evan. These are the flashovers, remember? Okay, so crown intactness. So this is a measure of how complete the crown structure is. So it doesn't matter if there are leaves or not leaves on the crown. So remember, imagine if the tree is perfect, so and compare what you see in your current tree to what a perfect crown would look like. And then you calculate the percentage of how good the crown is. So as I said, it doesn't matter if the tree has leaves. So for example, here the crown intactness is 100%, and you have 100 here, 100 here, and 100 here, because what we care is about the whole crown. So this is still a complete crown, even though it doesn't have leaves. Crown loss is the percentage of crown that is lost related to the disturbance. So there might be pieces of crown that are lost, but they are very old. So you can see that they might have broken a long time ago, and then you look on the ground and you don't see any branches, new branches fallen. So this might be that was lost a long time ago. So make sure you look for that what you are estimating at loss is related to the current disturbance. If there's no crown, of course, 100% of the crown was lost. Liana infestation index, we have two values. So liana observed is what you currently see in the tree. It doesn't matter what happened before, is what you currently see, so what you see right now in the tree. And liana index pre-damage means what you currently see adding what was there before the disturbance. So this is an example. Observe, you see this is a tree. Let's say this is a liana observed of score number 3. And then liana index pre-damage, you see what happens with the disturbance. So the disturbance broke this branch and it has a lot of lianas, plus the lianas that you are observing in the tree, which is the same number as here. So this will be maybe a number 4 in this score of crown covered by lianas. So this was probably 3 and this was probably 4, because we had included what happened after the disturbance. And then leaf presence is the percentage of branches still in the tree that have leaves. So let's say you see this. This is an example, for example. The crown intactness on this tree is 100%, but the leaf presence is probably a 75%. As you can see, like about 25% of the crown doesn't have leaves. This is a crown intactness of 100 and leaf presence is 0. And this will be crown intactness 100% and leaf presence 100%. In this case, for example, this is a crown intactness of 50%, and then leaf presence is 100% here, because you see all the branches in the tree have leaves. So crown intactness 50%, because 50% of the crown is lost, but leaf presence is 100%, because 100% of the branches that are in the tree have leaves. This is, in this example, we have crown intactness of 50%, so 50% of the crown was lost, but 0% leaf presence. Then biotic damage. Remember, the lesion is, you can see something like that, so it's it passed the bark, and you can measure the distance with the laser. If you see aggregation of beetle holes, of woodpecker holes, it would look like this, and these are beetle holes. Hard rod, remember, it will look like this. So the tree is hollow, so this is hard rod in the trunk, this is hard rod in the trunk, and you also can have hard rod in the branches. So when this branch fell, you can see if it's hollow, so if it has a hole inside. And then when you measure the disturbance, again, you have site ID, danum. Disturbance ID is the number in the blue polygon in the map. Longitude, latitude, this is with the GPS, and then you measure the length and the width of the disturbance, the numbers of potential flashovers. So it doesn't matter if you don't see clear evidence of lining, but if you see something that looks like flashover, please count them. Even though at the end you decide it's wind related disturbance, you still should count the potential flashovers. The liana load in the disturbance, this is the information for the scale, so make sure you read this. This is only from the disturbance. Soil characteristics is only for Duki in Manaus, so you skip this part. And then diagnosis. So this is everything that you see in the disturbance. You add these codes. And then the potential cause. You can use wind if you see there is a lot of broken trees. Some of the broken trees still have green leaves. Fresh broken wood. You can also see lining. As you remember, we tested this by looking at flashovers. And also, when you find lining, it is expected that the trees around the tree that was struck by lining has a lot of dead branches, and also a lot of the seedlings around the main tree died. And you can see something like this. So let's say this tree was struck by lightning, so there is a lot of flashovers, and most of the branches that are pointing towards the tree that was hit by lightning has flashovers, and the tips of the branches are dead. If you look in the understory, a lot of, let's say this tree here was struck by lightning, so you can see all the flashovers pointing towards this direction, and a lot of these smaller trees around this big tree should be dead or brown and are dying. If you see a lot of these flashovers and dead smaller trees around the big tree that was hit, is likely to be lining. So other standing, you write this down when the tree is still standing, so it didn't fall, but you check from the images from the previous month and this month. And last month you can see in the image that it was alive, and this month it is dead, but it's still standing, and you don't see any wind or lightning potential cause, so it will be other standing. There is also DB, died before drone detection, so you can also look at the photos and you can say, yeah, this tree was dead last month. So it likely died a long time ago, and it was just detected by the drone. And N as a non-disturbance giganticide. So this is what you will do if at the beginning you don't find any gigante trees. And you can mix them, so you can use multiple, like this. Not a gigante disturbance, but it's also caused by wind.